Hello, and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. For today's show, we've got a guest, which, to be honest, it's the second time round of trying to get a podcast. First time we had a few technical gremlins that meant that we couldn't use the audio. So Dane Davis from Nikola Motors very kindly agreed to come back on and have another go at recording the show. So welcome, Dane.
Welcome. Thank you very much. Good to be here.
Excellent. Thanks for joining us. So if we could just start out, Dane, with a bit of a background on you, be really cool to learn some more about you and where you're from.
Yeah, I'd be glad to. So I have a pretty unique background. I'm a mechanical engineer at heart, and I've been in the controls and system integration world for most of my career. I've done everything from MEMS technology to large Oshkosh trucks that do airport runway snow removal. And the thing that got me in the catalyst into the zero emission world and green technology, electrification, actually was through the hydraulic hybrid world. I developed a hydraulic hybrid system for Class 8 semi-trucks.
Oh, wow.
I did regenerative braking, stored the energy in hydraulic accumulators, and in the early days, it was a good fit because hydraulic technology was very developed and very mature.
Yeah.
And electrification was quite new, and it was still trying to be matured. And so I transitioned from the hydraulic world to electric world as technology improved. So.
Oh, wow. And so just to, for people who don't know, could you just explain very quickly how a hydraulic hybrid works?
Be glad to. The hydraulic hybrid system that I worked on was a parallel hydraulic hybrid system.
Okay.
The way that works is you have a traditional vehicle that has its powertrain, a diesel engine, transmission, and in parallel of the transmission, you put an additional transmission that recovers braking energy and launches the vehicle from the driveline as opposed to from the engine. And the idea is it reduces the carbon emissions because a lot of the carbon emissions that are emitted in diesel engines come during the acceleration events of the vehicle. That's a large percentage of them.
Yeah.
And so it curbed those acceleration emissions and reduced the emissions by 90%, and then it also increased the fuel economy by 30%.
Oh, wow.
So very different. It's a very dirty world, the hydraulics are, so.
Yeah. Simple, though. And I guess at the time, the advantage was you had a big reservoir of hydraulic fluid under pressure, quite high pressure, I guess, like to store the energy instead of batteries, which the batteries probably just weren't mature enough at the time.
Right. So the benefit of hydraulics is they're very power dense, and so you can get a lot of torque. And so what happens is you would spin up a motor and it turns into a pump, and it pumps fluid into a reservoir that is an accumulator that pressurizes.
Okay.
And so you have the stored pressure, and that stored pressure is then, when you accelerate, turned into launch pressure, and it would propel the vehicle forward. So you're always dissipating the full amount pretty much and recovering the full amount every time you go through an acceleration event. So there's no long-term storage of energy on the vehicle.
Wow. And that's pretty early, I guess, in hybridization and things for commercial vehicles. So what made you jump then into the electric world? So going from the hydraulic stuff into electric stuff.
Again, it was a short-term opportunity where it was a retrofit system, and I was introduced to Trevor Milton in his vision of making a true zero-emission vehicle. Right. And he had access to some technology from a electrification standpoint that was very intriguing to me. So I ended up leaving my business and joining him in his venture in Salt Lake about 4 years ago. 4
years ago. So, because I think one of the, Nikola has I've known you guys for a little while now, but you've really burst onto the scene in the last sort of few months. People have kind of really sat up and taken notice of what you're doing, but it's fairly safe to say, I mean, you're not. It frustrates me a bit because I've seen you described quite a few times as being a startup, but you're not. You've been in this for 4 years now, so quite a long time already down the line in vehicle development and powertrain development.
Yeah, typical from scratch vehicle development. If you look at commercial trucks, takes quite a while, and we don't have like chassis that we've used in the past. We don't have transmissions we've used in the past, and so to start this thing from a vision and build it from scratch, from the ground up, chassis, powertrain, batteries, cab, everything that you can think of that goes into a commercial truck that's electrified, didn't exist when we started about 4 or 5 years ago.
Yeah.
So we had to invent and develop a lot of the electrification elements, also bring partners that were in development of electrification and get them accelerating their plans to provide us solutions that were more commercially available. So that's why you see our partnerships with Bosch and other companies like that, where we've been able to accelerate some of their developments because they pretty much were waiting for a customer to say, hey, we've been kind of toying around playing in this field, but we don't really have anyone that's willing to make the jump. And Nikola said, that's our primary path. We need to make the jump. And so them understanding our business model, understanding kind of our timelines, they made that jump with us. And again, it's really accelerated our development. But yeah, so we're not a typical startup. We're not a brand new OEM that's hasn't been doing this. We've developed multiple prototypes and multiple development vehicles and gone through iterations of technologies. And so we've learned quite a bit. And then our company right now, I think we're up to 360, 370 employees.
Wow.
And are on target to grow, I think by the end of the year, over 500 employees to 600 employees with our new manufacturing facility not being even included. So
wow.
That's a big jump from when I started. There was 11 of us, and we were trying to keep our team small and leverage a lot of our partners. But at this point, we are ramping up our internal capabilities while we still leverage partners. So
right. And that your focus is very much over the last few years. I mean, there have been there are other business areas that you're getting into or in with the sort of utility vehicle and the new pickup truck. But really, the last few years has been all about developing that big. I don't quite. Is it Class 8 in America? Semi. Class 8. I always get really confused because it works differently in Europe, but big trucks basically. So it's the commercial vehicle industry, big trucks for long haul trucking.
Yep, big trucks. And we started with the most difficult problem to solve, which is long haul trucking.
Yeah.
It's very much a challenge to compete with an industry that's been around for so long that have pushed the envelope on the diesel front to figure out how to optimize those powertrains to the nth degree.
Yeah.
And it has an infrastructure out there that supports those trucks all over the world, right? And so we came up with a business plan that could actually disrupt and change the market to a zero emission hydrogen market,
right?
And which requires a lot, right, for us to actually execute on. And it was the most challenging problem to solve. And then in that, battery technology has been improving. So we're also developing and releasing next year a battery electric semi-truck as well for day delivery vehicles. So under 300 miles, battery electric trucks work really well with the current technology that's out there.
Yeah.
And anything over 300 miles, 500, 600, 700 miles, you need something that's a little bit more robust and quicker to charge and then get back on the road to meet the lifetime requirements and the cost targets for commercial trucking. So that's where the hydrogen comes in.
Okay.
The long haul.
And
again, it takes longer to certify. It takes longer to go through all the systems on a hydrogen vehicle.
Okay.
And also we've been testing our hydrogen systems to make sure that the fuel cells we provide have a lifetime expectancy that we need in order for our customers not to need to replace stacks, things like that.
And people sort of really overlook that, don't they? And how different commercial vehicles are to passenger cars. The life cycle requirement for passenger vehicles is, maybe 2,000, 5,000 hours, but commercial vehicles, they work all day.
20,000 hours plus, right?
Yeah.
And you're looking at 1,000,000 miles, up to 1,000,000 miles these trucks live.
Yeah.
And you beat the heck out of them during that lifetime.
Yeah. So it's quite unusual. I mean, today, basically, you wouldn't get components really transferring from passenger vehicles up into commercial vehicles because of the life cycle durability requirements. And I think for electrified parts, it's still, there's still a lot of challenges making passenger car parts suitable. So you guys have taken I think, a really interesting approach in terms of developing everything from scratch, but really because you had to, because you've got a very novel powertrain in your truck, haven't you?
Yeah, very, very novel. Our powertrain has so far been independent motor control. Each wheel has had its own motor.
Yeah.
We've had independent suspension. We went with that initially on the long haul trucks to reduce the transmission of vibrations into the chassis, and from the chassis to the components. There's a ton less vibrations anyway, because you don't have the big vibrations from a diesel engine beating the crap out of things at high frequencies. But it's been important, as an example, to look at the whole picture to figure out to optimize durability for these things in lifetime.
And so your motors then, because some people we get so many questions about in-wheel motors, but just to be clear, you're not talking about in-wheel. You got the motors are mounted inboard, aren't they, on the chassis, and they drive out to the wheel. So you've got a motor and then basically a customized gearbox for each driven wheel on the truck.
Yeah, so we have 6x4 and 6x2 variants for the truck. The 6x4 variant is a central gearbox for each axle in the rear.
Yeah.
And each motor has its independent gear set that goes to an output shaft right directly to the wheel.
Wow.
The 6x2 option, we've also developed an axle that's a differential axle. So 2 motors on a single differential that drives the wheels directly, and it has a more traditional suspension, and that's what we use for our BEV trucks.
Okay. Right.
So we have both variants and flavors.
Because the independent suspension is like groundbreaking. I don't know is there another commercial vehicle with independent suspension on the back? No,
it's actually we own the design and patent for that, and we developed that with Meritor, and it's an adaptation from military vehicles they have developed with military for off-road capabilities and kind of more flexible type of chassis they have to design around.
Oh wow, cool. So could you tell us, you've gone for individual wheel motors. Was there a particular sort of performance requirement or reason that drove that? What was the sort of thinking behind that rather than one huge motor?
Again, we wanted to make it commercially viable. So finding motors that fit in the application that would meet the kind of price targets and durability and efficiency targets that we're looking for. We found a motor that's very, very efficient and very, very high speed, high torque. But it's optimized for what's, again, right now commercially available. So independent motors allows us to do additional things like torque vectoring, torque braking, and regen braking on each wheel. So there's a lot of advanced controls we can do that even help us on our ADAS side, because we have a redundant steering in the torque distribution as well.
Oh, wow.
So there's some benefits that we gain from it, but ideally it's also been to make it so it's a commercially viable solution that we can source and lock in the source for those components.
Yeah, okay, I see that. Some of the established OEMs where they're kind of trying to do effectively a conversion, so they're taking an existing chassis powertrain and taking the diesel engine out and putting basically a big motor in where the engine was. That kind of has issues with, they have no space to put batteries and things like that because they've got the prop shaft and all the other sort of the bits in the way. So you must give you some advantages from a packaging point of view as well.
Yeah, exactly. A lot of the solutions you see out there, I mean, I've looked at a ton of them, but these retrofit systems, they typically keep their rear axle the same, and they bring a drive shaft out of that rear axle into a motor gearbox that is typically a very large motor and either a single speed or a multi-speed gearbox that can actually transfer the torque from the motor to the wheels. Now you've taken up all that space with an axle from the axle to the motor with the drive line and that large motor in the middle of the frame rails, and you've taken the capability out to integrate any battery or any storage in that area.
Yeah.
Our battery electric vehicle has a fully integrated axle, so everything's built into the axle, and there's all the space from the front of the axle all the way to the front wheels is available for storage of battery, which allows us to build a battery for this truck of over 720 kilowatt hours. The largest battery I've ever seen in any commercial truck out there. And honestly, our vehicle is the first and only Class A vehicle that I know of that's commercially viable for Class A trucks. I mean, there's some Class 6 ones that are out there that are prototyping that are both hydrogen and battery electric. And then there's some prototype demo ones, like the Tesla one's a prototype demo truck that they want to do a Class A vehicle. But really, the only one that's been out there in demos for like commercialization is Class 6. So we're still quite a bit ahead in the industry. We have a lot of people at our tails trying to catch us.
Yeah.
And I think because of the path we took to do things from scratch and develop it as a ground up new development, it allows us to have those architectures ready that allows us to put the storage we need on there, keep our weight down. Yeah. And it's pretty exciting.
So another question on the powertrain front, and it sort of feeds off that topic of people trying to use off-the-shelf stuff versus custom development. So for commercial vehicles, one of the sort of areas where people talk a lot about what the right approach is the system voltage. So you've got some people who advocate the kind of lower voltage that ties more into the sort of where the passenger car industry are at. Some people talk about some really high voltages, like 2,000 volts, sort of some crazy stuff. Where did you guys end up landing on system voltage? Can you talk about that?
Yeah, our system voltage, we're an 800 volt architecture for our semi trucks, and that provides us with enough for the applications, enough speed of charging.
Yeah.
For the batteries, as well as taking advantage of commercially viable 800 volt system components that are out there. If you start getting to the 2,000 volts and these crazy voltages above, now you have way more DC-DC developments and things like that you have to also again start from scratch. And maybe we go there in the next couple of years because of lower currents. Maybe it helps reduce weight and things like that. But right now, to get to market for next year, 800 volts is really the only way to go.
Yeah. Okay. Cool. And that's still
low,
Well, and I think you say that very casually about the 800 volts, but it's really like not many people are running 800 volts already. And particularly when you guys started doing this, no one was running 800 volts. It's like super unusual. I think the Taycan was the first production car on the road. It's quite unusual in terms of people going up to that level. So it's, I think, a big brave decision, but which actually now is looking like, because lots of people are following on that 800 volts level. So it does look like it was the right decision for you guys to make.
Well, not many commercial trucks can wait 8 hours to 16 hours to charge a vehicle.
Yeah.
And so if you use a 400 volt architecture, you just cannot meet the targets for the customers. They have to be able to get in and out and charge it in a reasonable time frame.
Yeah.
And they're building their own infrastructure anyway to do this at their ports or at their destinations. And so you're not going to be typically pulling up to a Tesla charging station that's out there for Tesla cars, plugging semi trucks in. It's just not a viable type of solution. And so they're to meet the missions that they need from a customer standpoint. They have to have enough energy on board to get out and back to their home base for battery electric trucks.
Yeah.
And so there's really no benefit to I'm not going to stop at some gas station and top off my batteries in the middle of the delivery. That just, you lose money doing it.
Yeah. The other electric car owners might get a bit annoyed as well with the Class 8 blocking the charge spaces. Yeah. So the other big element in your powertrain is the fuel cell. And fuel cells are quite a polarizing technology. Some people love them, some people hate them. What's it been like to try and practically commercialize a fuel cell in an application like this? Because I think, again, you guys are really ahead of the curve here in that I know fuel cells in the Chinese market in sort of, fairly decent numbers and in some kind of other applications that are very specialized. But you're going to be one of the very first kind of high volume production fuel cell vehicles going out onto the road. So that must have been full of challenges in terms of getting the fuel cells to work properly and at the right sort of maturity level.
Yep. And again, it's been this whole, it has been a big debate, right? Fuel cells versus battery, fuel cells versus battery. Fuel cells, as some people want to call them, right?
I didn't want to say that. Yeah.
Basically, the fuel cells for the vehicle are a great technology for the application.
Yeah.
Again, not every application needs this type of technology. It would make no sense to put this kind of technology into a passenger car for most applications and most industries at this point, because it's just not there and it's not needed. You can usually meet your requirements with a battery on those applications. But commercially, it just stores so much more energy on board.
Yeah.
And you want to keep the weight so low so they can actually deliver goods from point A to point B. Every pound you add to the chassis, every pound you add to the powertrain takes away from money in the pocket from the people that are delivering goods.
Yeah.
And there are limitations in the industry that says you can't exceed certain axle loads on every axle. So there's, in the United States and over in Europe, there are requirements that each axle can't exceed certain amounts to meet bridge design.
Yeah.
Right. So you have to not be damaging bridges and roads. So this is an inherent problem of battery electric storage. Is it's super heavy.
Yeah.
So it's if I could get a battery electric truck that weighed almost nothing or exactly what a diesel would, we'd do battery electric all day long because it's much more efficient.
Yeah.
But because there is no battery out there, there is no technology, and the roadmap for that is not in time for really solving the zero emission problem. Fuel cells work really good. You look at some of the best automakers in the world, Toyota, for example, they have a roadmap to replace every vehicle in Japan with a fuel cell vehicle.
Yeah.
Right. And zero emission. So they're looking at a whole infrastructure over there to have a hydrogen infrastructure that does both commercial trucks and passenger cars. And they've developed the Toyota Mirai. You got Hyundai developing fuel cell trucks and fuel cell cars and SUVs. And so it's a race. And you look at kind of the traditional OEMs in the U.S., they've not really been off center. They don't really know which way to go or jump into.
Yeah.
And you have the disruptors like Tesla saying, okay, we're going to do all electric, battery electric, and they're going to push that envelope as far as they can go.
Yeah.
And you got the slowest moving, but I think highest quality vehicles that are out there are Toyotas.
Yeah.
And they're very conservative on the technologies they select and they work with. And I think it says a lot that they are 100% in on hydrogen fuel cell vehicles and have no battery electric only vehicles that I know of on the roadmap. So again, there's just, you kind of look at the whole breadth of the industry and the market, and there's a lot to take in to understand who the players are and who's pushing for what.
Yeah. And that segues in actually. So one of the comments that we often get about fuel cells is on the efficiency point. So you've got the cost and efficiency, energy efficiency to generate the hydrogen in the first place, but then the cost and the sort of efficiency in terms of the energy conversion on the truck. So what's your thinking on that? I mean, I've seen people recently trying to say that basically fuel cells end up more expensive to operate than diesel, but I don't know. Do you think that's right, and you get the zero emission benefit, or do you see basically a total cost of ownership benefit over a conventional diesel? That's about 6 questions all in one there. So if you want to unpick that a little bit, feel free. So fuel cell efficiency, what do you think about that? And how does the total cost of ownership work out compared to a diesel truck? There's the 2 questions.
Well, first and foremost, I hate inefficiencies because what that does is it requires more cooling on the vehicle. And so efficiency is always expelled through heat.
Yeah.
It's not through emissions. It's not through any kind of negative impact on the environment. It just makes our challenge much more challenging because now we have to cool the system to meet the requirements for the efficiency loss.
Yeah.
Now, if you talk about whether it's more expensive or not, or why you pick one or the other, it's really the total cost of ownership and money in the pocket for the operator owner of really, will they make money on this? Will it be more expensive than diesel or not? So efficiencies are only a factor if that becomes a problem.
Okay.
So if now they cannot get fuel at a price that makes them money, or they cannot get to point A to point B with enough energy on board, then all of a sudden they don't have a business model.
Yeah.
So in our business model and in our negotiations, we're doing long-term contracts for both electricity and for building our stations.
Yeah.
That is something that we hyper focus on to make sure we can meet those targets for the cost of electricity and the cost of the systems, the maintenance of the systems to produce the hydrogen.
Okay.
And so again, that's a big problem, but that's all part of the equation. So yeah, we'd hate to give up that 30% efficiency, for example.
Yep.
But it's something we have to build into the business model to accommodate, so we can still beat diesels in a cost per mile race.
And just picking up on that, when you say the cost of electricity, that's because you're building an infrastructure of electrolyzers, basically, aren't you? So you're going to be, it's all going to be green hydrogen. So no kind of, is it grey or blue? Blue. No blue hydrogen in your network.
As much as possible. Yeah. So we're building up. The benefit of our stations is we are oversizing them.
Okay.
And we want to produce hydrogen when green electricity is available to us.
Okay.
We'll be buying green electricity, and that's the big challenge with the current infrastructure of the electricity in the world today.
Yeah.
Is there is a threshold in which building more wind turbines, building more solar fields becomes a huge challenge to the grid, because you have a very peak demand and you have a peak production.
Yeah.
And those do not match up at all in any industry that I know of for producing electricity when it comes to green. And so to do that, they have to turn on and off the blue or the brown or the different types of electricity, and they have to scale up nuclear, scale up or down coal, that type of stuff to balance the grid.
Yeah.
And so that's why these people are working on battery storage systems and stuff like that. But we can take the electricity directly in an instant.
Yeah.
And we can produce hydrogen and store the hydrogen on board for our stations and turn it off. So if they have a peak like windstorm that comes through, we can produce a ton of hydrogen, right? And we don't have to turn off megawatts of power. They can literally just give it to us for pennies. And we can create hydrogen. We're like, awesome. Same thing with solar. When you have great solar days and they don't have to turn down their other plants to do what they need to do for the balance of the grid.
Yeah.
And so it's a really big grid balancing benefit, which will help us scale up in the world to more and more green energy being produced.
Yeah.
And it'll be able to take the load off of the need for some of this brown energy or the other energy that has to be produced to balance grid right now.
Oh, fantastic. So essentially the model is that you'll be able to use electricity from the grid when it's at low demand from the rest of the grid. So you can buy it, I guess, probably more cheaply to generate hydrogen that then you guys can store in your hydrogen stations to when the trip comes in that it needs it. And then essentially the station will recharge itself again at leisure, utilizing the best mix of lowest cost electricity, greenest electricity, etc., coming from the grid.
Yep. And in that, we've also partnered with the largest producer of solar cells, Hanwha, where they're able to scale up their production of solar cells and solar fields and start contracting these areas to help sell us electricity, right?
Oh, wow. Yeah.
So it's, again, expanding the green technology that's out there and taking that green energy and producing hydrogen from it. It's
amazing.
I hate the chicken and the egg analysis, but it's kind of both, right?
Yeah, no, I can. Now you've said it, it just seems so obvious, and particularly for a truck, because I think people are looking at so charge stations. I know a few guys who are involved in this sort of business where they are doing grid support batteries. And one of the things, I don't know if in the US it's happening, but in Europe, sometimes for a car charging station, you know, if you want to have 20 charge points for cars, people are dropping a battery in as well to kind of so they don't have to put such a big incoming feed in from the grid, so the battery kind of buffers it all out. But I know people are starting to hit issues when basically it turns into a bus depot, because the battery you need is so huge. So you end up with a very expensive grid connection and having to sort all that out, and a huge battery and an expensive battery. But your approach is kind of using the electrolyzer and storing the hydrogen. So you've got a smaller overall system there, and you're able to basically work with a smaller grid feed, because you're all about trucks. So all of these refueling points are going to be just for trucks, where you need to be able to smack a huge amount of energy into the truck very quickly, so it can get on its way. So it's a great model. I had a question on the fuel cell. I don't know if you can tell us this or not, but so in the last few weeks, last couple of months, we've done some really interesting podcasts with a couple of different companies who do fuel cell technology. So we talked to some guys who do PEM fuel cells, and some other guys who do SOFC fuel cells. Which kind are you using in the truck? Are you SOFC or are you PEM? So low temperature PEM, or the more sort of steel cell, high temperature SOFC?
So the current one that we're developing right now, putting in the truck, is a PEM cell.
Okay.
And again, we're up to speed on all the different fuel cell technologies out there, and we have a roadmap to make sure we stay ahead of the curve to have the most efficient, most durable, and reliable, and efficient fuel cell out there. But to get to production in a time frame, we're finalizing our PEM fuel cell development right now.
Okay.
It's in partnership with Bosch, which has been publicly announced, and so Bosch is helping us manufacture and produce our fuel cell at the Nikola fuel cell, and they're experts in commercialization of automotive components, and so they'll make this thing with us as robust as it ever could be, right?
They make good baseball caps as well. We're not recording this, but Dane's wearing a Bosch baseball cap.
So the other thing I wanted to also mention with fuel cells, which is something that maybe people do not remember or think about, is the sustainability of the materials being used in these different systems. It's going to be a challenge, and it is a challenge currently in the world, the recycling of battery technology, and also the materials that are being sourced for those batteries being kind of confrontational, right? It's not the best in the world, this battery source and disposal. But a fuel cell, 99% of that stuff can be recycled.
Right.
It's not a lot of components in there that can't be reused and built into another fuel cell or another vehicle.
Yeah.
It's a very recyclable, sustainable system from the beginning to end in the life. And of course, that's a huge benefit from a powertrain that we see as well.
Especially given the size of battery packs potentially that you need in these trucks. So you're 10, 15 times the problem that a passenger car would have. So that's a really good point in terms of that sustainability, recyclability of the materials, because it is a big topic which people keep talking about. There's big stuff the last couple of weeks about nickel production. Obviously, cobalt's controversial in terms of cobalt production, and lithium itself actually a bit of there's difficulties around that too. So that's it's going to be a big part of the sort of discussion moving forwards as we're trying to make everything much cleaner. So yeah. Moving on then, Dane, you've done the IPO, and you also completely moved. So you mentioned earlier when the business started, you guys were in Salt Lake City, and you moved to Phoenix in Arizona, right?
Yep. We're in Phoenix.
And I was just wondering about the sort of reasons behind that. So and what's it been like? Because obviously it's not. I don't know. In the UK particularly, that would be quite unusual. And because all the staff moved as well. So in Europe, people don't tend to do that. But I sort of looked on with amazement as everyone just kind of it was almost just sort of, I don't know. No one even seemed to question it. So first of all, why did you move? And then what's it been like to do such a big move like that?
Let me start with, it wasn't like no big deal. It was a big deal. Well,
Yeah.
I have 6 kids, and my wife
Wow.
was very anxious about moving.
Yeah.
She'd always lived in Utah
Yeah.
her whole life, and so to make this move and make a decision as a family, this is the move we were going to make. With such a new company and a new technology it was a challenge for pretty much every employee to make that determination whether they'd move or not.
Okay.
It wasn't just a fly-by-night decision. That being said, I was very impressed. We only lost like 2 or 3 people through the move, and everyone else decided to move down with us, which is about 35 to 40 employees at that point. And so that speaks volumes of our commitment and our belief in what we're doing. It is something that we were willing to disrupt our families to make happen. And it's panned out so far, right? We have made a lot of progress. But the reason for the move is we had to find a place that would be suitable for our manufacturing facility and a workforce that could support that manufacturing. And we went to many states. We evaluated the benefits and kind of the interest of those states to help us get things up and running, because it does take a lot of red tape trying to allow a new manufacturing facility to get up and running. And who was going to help us get through that red tape the best? And Arizona honestly came back with the winning argument and the winning offer. And so they also, in Phoenix, it's a city of about 5 million people. It's the 5th largest city in the United States, and so the access to universities there and workforce and ability to expand their capabilities in Phoenix is something that we were very interested in.
It's much bigger than Salt Lake, really. Much
bigger than Salt Lake. Salt Lake's maybe it's less than 1 million in Salt Lake.
I didn't realize there was such a huge difference. No, wow.
Yeah.
Okay.
And so those are some of the reasons why we moved down. And when we moved down here, it has been a little bit easier to recruit, and we've had people, and our company's grown really well.
We've added 300 people in about a year.
Yeah, and it's accelerating. In our manufacturing, we're going to be manufacturing in Coolidge. We just broke ground to our Coolidge manufacturing facility. We anticipate about 2,000 employees out of that facility. We start hiring for that, I believe, this year, and we start producing trucks out of that facility in phase 1 next year. Wow. So there's 3 phases of that build for the factory, and the first phase will be up and running next year with the new hires for that facility. So again, a lot to do in a short time, but we keep amping up the pace. So
faster and faster. And your sort of headquarters building, the engineering facility, was that a new building, or was that an existing building that you've converted across? I can't quite remember.
So it was the 4 walls were up and the ceiling was on, but we took off the ceiling and we redid the entire side because there were no walls or anything, and built it up to be a Nikola headquarters. And we put our hydrogen station on site as well.
Right.
So it did help us that the 4 walls were up, but we basically built everything.
And it looks amazing. I mean, if people, I'll put some links in the show notes to it, but it's enviable facilities. I mean, the gym is something to behold apart from anything. So, I don't know, do you actually have the time to go in the gym?
I used to. COVID has kind of put a wrench in my exercise plan. So I have the gym because I work from home, or I've been working remote a little bit more often.
Yeah.
But it's still used. It's open anytime the employees want to go in. It's a very, very nice gym. The nicest gym I've ever worked in. And it's pretty fun. And then the rest of the facility it's a very open layout. So we have a lot of collaborative spaces that we can work together, and we have a central collaborative space that everyone comes and does all their meetings in.
Yep.
So it allows us for a lot of open communication. We don't want to have a lot of silos in the company. It's one of the most unique cultures of a company I've ever worked in, and it's the most, I tell people this when they interview, it'll be the funnest place you work, and also the hardest. It's super exciting. People don't come in and stay late hours because they're yelled at and they're told they have to. They come because they really want to change things. They really want to make a difference. So there's quite a few people that work a lot of hours, but just the type of people and the type of culture of working there were just all, again, a very unique bunch of people.
Yeah.
It may be odd a little bit, I don't know, but it's a fun place to work, and it's a very, I think the best word I've heard to describe it is collegial.
Okay, yeah, and that comes from you guys, right? So, yourself, Trevor, the people who've been there right from the start. So, what is Trevor like to work with? You can tell me. Go on.
He is challenging. I could say that. He challenges us every day.
Yeah.
And he wants to push the envelope. And I love his attitude of can do. He doesn't like to think of things of why they can't work. He likes to think of how can we make things work.
Yeah.
But it does put a challenge on engineers when he says, okay, this is what we're doing. And we say, Trevor, that's not a thing. That's not possible. And so we work with him and we work together, and we understand a little bit more his vision of what he wants, and he pushes us past boundaries that we're really weren't willing to consider initially, because we engineers love the easy path. We love to make sure it's guaranteed success. It's engineered, just it's already done almost, right, and you're just integrating it.
Yeah.
But we've really been able to push past a lot of those boundaries and push the envelope, and it's been fun.
Oh, brilliant.
But yeah, he's a fun guy to work for too. Another thing about Trevor, he's the most personal and personable CEO I've ever worked for. A lot of these driven guys that are basically driven to make success are willing to plow through anyone to get there.
Yeah.
And when push comes to shove, they'll chew your ear off and make you feel this small.
Yeah.
And that's not a fun environment to work in. I've never had Trevor do that to me, or I've never seen Trevor do that to anybody in the company.
Yeah.
He's very compassionate. He wants to improve the lives of his employees.
Yeah.
But he doesn't accept no. Oftentimes, he considers your input, but he wants to push you.
Yeah.
But he does it in a very compassionate way. And then he's very generous to us in the way that he treats us as employees. So I really appreciate that, him as a person, Trevor's, and that has to do with the culture, right?
Yeah.
So that breeds a culture in the company where we are also encouraged to be helpful to each other and not demeaning, or we're not trying to build ourselves up to some like, okay, I have this title, right? I'm a CTO for Nikola,
yeah,
but that doesn't really mean much inside of Nikola. I just work alongside everybody.
Yeah.
And it's just a lot of fun to work with everybody, and everyone has good input. And when it comes to decisions, the buck stops at places, but
yeah,
it's a very open culture where we work together to get stuff done.
I think that's so important. It's a lot of companies sort of pay lip service, I think, to the importance of culture and the importance of treating your staff right. You often hear people talk about our staff are our most important asset, but then they don't really act like that. They're just saying it because they have to, and you can feel the second you walk through the door, you can taste the difference in companies that really take that seriously, where they have that really strong can-do culture and spirit. I absolutely love that. I think it's so important, particularly you guys are doing something that's really hard. Like it's a very, very big challenge you're trying to change an entire industry that, to be frank, doesn't particularly want to be changed. So it's a tough challenge to get the product right, to get the industry acceptance, etc. So you absolutely have to have a strong culture to underpin that. Yeah.
It also helps with building the relationships and partnerships that we've needed to develop.
Yeah.
So I can guarantee that we wouldn't have been able to develop the relationships with Bosch or with CNH, Iveco, if we didn't have the team that we have in place today and the culture that we have in place. No one wants to work with a company that's difficult to work with. There are people that are difficult to work with. And even in the investor world, as we got long-term investors in, we had a lot of people come through and evaluate our company. And the things that I heard most from them, besides that they loved our technology, they loved where we're going, they loved our business model, was they believed in our team, and they saw how we kept retention of our team and the type of people that we have on board.
Yeah.
And they're buying into us as much as they're buying into the idea.
Yeah.
And great people can make amazing things happen as long as we're driven and we stay focused and we can all push together. If you start fighting against each other, there's no way in hell this will happen. I'm just saying, right?
Yeah.
It's hard enough. It's hard enough. And so that's a big reason why we've been able to make the steps we've been making, is because of the people, along with the technology and business plan.
And I know all too well the challenges that you talk about there. So you mentioned investors. Obviously, the IPO was a big deal. So technically, was it a reverse takeover rather than an IPO?
Yeah, reverse acquisition. Special acquisition.
So you're now listed on the stock exchange, and has that changed much? You've gone from being a small, like a privately held company, kind of hidden, tucked away, to being so much in the public eye and a listed business. Has that changed how you guys have to work?
Not very much. What it does change is we have to have a lot more accounting and legal people on board to make sure we do our filings, and we communicate a lot more to the outside world what's going on every quarter. So there's been a lot of growth in that side of the business. Okay. It's also put a lot of pressure on us because we have to meet. It's not just like we run out of money, right? Yeah. We have to meet deliverable dates. So when we say we're going to production next year and we start promising those dates, there is a lot of accountability that we talk about every week. Yeah. To say, okay, are we on track? What are the risks? How do we pull it forward? Because we know that the market's not going to be forgiving from us going backwards on what we say. Yeah. Because we can't show earnings, we have to show deliverables, right? Yeah. We're still pre revenue. Yeah. And so getting revenue as quickly as possible and delivering on what we say we were ready for, and we are ready for, is something that just puts a lot more focus on the team to make sure we deliver on those deliverables. So that's the main focus. I mean, it does help us in some ways because we're able to get the money that we need to grow the business and build the factory. Yeah. But also give a little bit more incentive to actually deliver, and not say, well, we can wait 6 more months or whatnot. We don't intentionally do that, but you know how projects do. There's always improvements you want to make. Yeah,
finding that point where it is good enough is the trick to managing an engineering group. Basically, it's there's always something else you can do, and everyone wants to add features and benefits and just do another round of testing and just difficult thing, really difficult challenge.
So at this point, our specs frozen on our trucks in pre-production, and we're going through validation testing. So the pencils are down. Yeah, and we don't have a chance to add really. So it's a different phase, right? I like the invention phase. That's my favorite phase of development, is creating something new that's not been done before. Yeah. This production phase is just a lot of work, and it's important and it's good that we have it, but it's less fun for me. I love the first phase.
Yeah, and so going into that productionization phase, you said sort of the pencils are down. Will there be kind of any changes to the vehicle as it goes through the next sort of steps on its way to getting into series production? What are you? Will you kind of? Do you think there'll be any significant changes, or do you think it'll kind of just get into production as is?
Well, there could be some changes based on what comes out of the reliability and durability testing. Okay. But with partnering with Iveco, that's produced trucks for decades, and understanding their capabilities to run accelerated testing both in simulation and in real life, we don't anticipate major changes in the chassis, suspension, structure of the vehicle, and the powertrain. All that stuff is something we'll probably find small little bugs or things of fixing wires a little bit differently here or there, or rubbing hoses, that type of stuff you find in any vehicle that you develop for the first time. Yeah, but not significant. It is what it is, and it's an awesome truck, the Nikola train.
Cool. So you mentioned Iveco, CNH. So I think it confuses me, to be honest. But just I'll kind of sort of preamble this. So CNH is the sort of commercial vehicle brand, which Iveco is part of. So it used to be part of the Fiat Group, So essentially, Fiat Automobiles had a commercial vehicle and a construction equipment division. The construction equipment and agricultural vehicles were always marketed under the CNH brand, so Case New Holland, people will know that. They had the Iveco truck brand, various other different bus and truck brands as well. But when they split the company into two, so they had the commercial vehicle business and the passenger vehicle business, they branded the commercial vehicle business CNH Industrial, and it confuses a lot of people. But you've got this relationship now with CNH. You mentioned a couple of times. So can you tell us about that? What is the relationship? How are you working with them? Are they going to help you with the trucks for the US market? Because they're not really, as a truck brand, they're not really active in North America. Or is it mainly for the European market? How is that working out with CNH?
That's a good question. Joint development with CNHI is the parent company. Iveco is their commercial truck arm for that parent company. And the CNHI Iveco partnership is we get to share in their development of the vehicle for Europe.
Yeah.
And there'll be Nikola trucks in Europe.
Okay.
But we can use their distribution, their service network, all that stuff for Europe because they do Europe and in other parts of the world, Iveco trucks.
Yeah.
And so there'll be a Nikola truck that leverages and partners in doing that for Europe. The U.S. side, they're actually taking our trucks for the first trucks and building them in Europe and shipping them to the U.S. for the first initial production until our facility is up and running. So we actually have a factory that we're ramping up over there that will be our European factory.
Yeah.
But U.S. trucks are coming out the line initially.
Okay.
And then we'll be transitioning into building them over here. So they're helping us ramp up our factory in the U.S. from their expertise of building trucks. And they're also helping us build our initial trucks in Europe and for the U.S. So that's kind of the way the partnership works. And we're kind of married at the hip.
Fantastic. So just to wrap up then, Dane, what are you most excited about in the next year? I know you've got so much going on. You must be excited about loads of things, but what are you most excited about in the coming year?
I'm most excited to get a truck in customers' hands and delivering freight.
Yeah.
That's going to be the most exciting thing for me is to be able to show that, hey, this is a real truck that does amazing. It's got the longest range of any battery electric truck in the market.
Yeah.
It also has the lowest weight and best in class and everything that we can and have worked so hard to get there. Also to demonstrate and show our next generation fuel cell trucks and in the roadmap to getting those out for 2023. So that is also super exciting for me. There's just so many. This next year is going to be insane for Nikola. We thought the last few years were crazy. I mean, think about it. Nikola's going to have a manufacturing facility up and running next year. We're going to have production and running trucks with customers. We're going to have our first stations up and running. And so there's going to be a ton of firsts for Nikola and groundbreaking events for Nikola. Yeah. Not just from a factory standpoint, but from a milestone. And so I just see Nikola really taking that and finding great success in it because there's been a lot building up to allow us to do this. And so it's exciting to open the gates and let these horses out.
Yeah. Oh, fantastic. So that's great. Thank you so much for taking the time out. We said a few times how busy you are. You've got loads of things on. So I really appreciate you taking the time to do this with me today. Thank you.
My pleasure. Thanks again for inviting me. Have a good one.
That's all we've got time for today on the Avid podcast. So that's been really fascinating talking to Dane. The Nikola story is an amazing one. I know there's a lot of haters out there, so people who kind of don't believe what they've got or, all this. I think a lot of the criticism that they get is really uncalled for and unjustified. But I guess that's kind of what happens when you become a listed company, particularly in the US, where people make money out of shorting businesses and such like. So I really wish Nikola all the success. I wish Dane all the success in the future. He's an absolutely fantastic guy. Brilliant team they've got there. I hope you've got some value out of that too. Don't forget to subscribe. So still a lot of people listening to the podcast who haven't subscribed. Make sure you subscribe. You get the updates when we release new episodes. We've had some absolutely amazing comments and feedback recently. So thank you very much if you're listening and you left us a comment or some feedback recently. Really appreciate that. It's so good to get those comments and that feedback. Don't forget, if you've got a question to ask or you have a comment or you give us some feedback, please do that. It really helps the podcast. It helps get it out there in front of more people. And when you hit like or give us a rating and engage with us on those comments and feedback. So please don't forget to do that. So thank you. And I really look forward to speaking to you again soon.